Okay, so question 2. Ethane, ethene, and ethyne each consists of 2 carbon atoms but a different number of hydrogen atoms. Which molecule are each of the Lewis structures? Okay, which molecule are each of the Lewis structures and electron and molecular geometry pair associated with? Note that the geometries given correspond to the geometries associated with the carbon atoms only. So here they just have, like it's one of those interactive questions where if you have ethane, ethene, or ethyne, you kind of label which of these electron and molecular geometry pairs associates with that structure and also with that chemical compound. So let's start off with ethane. Ethane has the structure C2H6, and even just by looking at the suffix of ethane, we know that it only contains single bonds. So it will have the 2 carbons single bonded together, and then all around are all of the hydrogens. Okay, so this is the structure of ethane, just all with single bonded hydrogens. And now if we analyze this Lewis structure, we, judging by the central carbon atoms, we see that there are 0 lone pairs. And we have 4 bonded atoms. Okay, so to help us answer this question, we can look up a helpful Vesper theory table. So I like to use this one because it has all the different columns that have hybridization and bond angles. And if we pair up the structure that has 0 lone pairs and 4 bonded atoms, we get this tetrahedral molecular shape and electron geometry. I'm just going to write that down over here. So when our central atom contains no lone pairs, then its molecular shape and electron geometry will be the same. So in the case of the 4 bonded atoms and 0 lone pairs, tetrahedral is the molecular shape. And the electron geometry. And the type of hybridization is called sp3 hybridization. Okay, so now let's look at ethene. And its chemical formula is C2H4. So again, if we look at its name, the prefix eth tells us there's 2 carbons in the chain, and the fact that it ends in ene means that there is a double bond in between the 2 carbons. So we can say that its Lewis structure contains the carbon double bonded with the other carbon, And then we just fill in all the bonds, the remaining bonds with hydrogens. So now we have the structure for ethene. So again, let's look at the number of lone pairs and the bonded atoms. So again, this central atom contains 0 lone pairs, but this time there are only 3 bonded atoms to our carbon atom. So each carbon is bonded with 2 hydrogens and the other carbon. So now if we use the Vesper table to find out the type of shape we have, 3 bonded atoms and 0 lone pairs corresponds to a trigonal planar molecular shape and electron geometry. So I'm just going to write trigonal planar. And I'll just put in brackets for both molecular shape and electron geometry. And this time we have sp2 hybridization. Okay, so lastly we have ethyne. C2H2. So this ends in -ine. So this means that there is a triple bond in between our 2 carbons. And since carbon wants 4 bonds in total, I'm just going to draw the 1 hydrogen attached to each carbon. And now we have the Lewis structure for ethyne. So if we analyze the Lewis structure, there are still 0 lone pairs for carbon, and this time there are only 2 bonded atoms. And according to our Vesper theory table, when we have 2 bonded atoms and 0 lone pairs, we have a linear molecular shape and also a linear electron geometry. So I'm just going to say linear for both. And this time we have sp hybridization. Okay, so these are our 3 compounds, and I believe we answered all the questions, all the sub-questions in this question. Let's see what the junior tutor said. Obtaining the steric number of the carbon atom would be helpful to determine the geometry of the given compounds, where Sn is equal to the lone pair plus the bonds around the atom. So so here they just define it as Sn steric number. Lp is the number of lone electron pairs around the atom, and B is the number of bonds around the atom. So this is a different approach, but it's basically doing the same thing. The table below shows the corresponding geometries for a given steric number. So when you have a steric number of 2, you have linear, and when you have 0 lone pairs, it's going to be the same. 3 is trigonal planar, 4 is tetrahedral. The Lewis structure for ethane is shown below. Okay, so they have the same structure and also got tetrahedral. For ethene, they have the double bond and they have trigonal planar. And then for ethyne, they have the triple bond and a linear electron geometry and molecular geometry. So this solution is correct. I'm also going to say we can use the Vesper theory table to solve the answer. Sometimes this the Vesper theory table is given in the quiz or in the test, so it's also good to know how to use it because it gives off a lot of information.